Alright guys, so this is video assessment number 4C, and the problem states a 4-meter long string is tied to a 0.05-meter radius cylinder and rotated at a constant angular velocity of 0.5 radians per second. How much time does it take to wind the whole 4-meter string around the cylinder? So to begin by solving this equation, we want to find out the angular position of the string as it's wrapped around. And the way we can do that is by taking this equation, arc length is equal to the radius times the angular position in radians. And so our arc length is going to be 4 meters long. And we have our radius 0.05 meters. When we isolate the angular position, we get 4 divided 0.05. So that's going to equal 80 radians. Then we can take this 80 radians and plug it into our time/period formula, which is going to be T is equal to the angular position divided by the angular velocity. And so we already know these two, so when we plug in our values, we have 80 radians divided by 0.5 radians per second. We end up with 160 seconds. Therefore, guys, it'll take 160 seconds to wrap around the 4-meter string around the cylinder. So, the reason why we use this equation right here is because in order to represent one full revolution, we usually represent it as the radians of full revolution is equal to the circumference of a circle divided by the radius. And so these will cancel out. And so what you basically get is 2 pi radians, which we know is 1 revolution around a circle. But we don't want to just find 1 revolution. We want to find, however long 4 meters is for a revolution. So we replace 2 pi r, which would be a 1 revolution, with 4. So that's what gives us our 80 rads. This doesn't tell us 1 full revolution. This tells us basically the amount of 4 meters as it would wrap around. Yeah. Thanks, guys.